So my question here is that what is the minimum velocity needed by the man to complete a loop? The diameter of the tunnel is given to be 7.5 meter. The key concepts that we need here are number 1, conservation of energy, and number 2, the concept of centripetal force. So now let's reform this question. The question is that suppose I have a string tied to a bob. Now, what is the minimum velocity required by this bob so that it can complete a full loop? What I mean to say is that suppose if I give a certain velocity, it will go to some height and then it will fall. If I give a greater velocity than the previous velocity, then the bob will go to a greater height, then it will fall. But after some time, there will come a certain velocity after which this bob will complete a full loop. So what is this velocity? I mean, how can I calculate it? So here's a point that if I give it the minimum velocity at this point, then after reaching the topmost point, it will have the minimum velocity only. I mean, the velocity will decrease, but the velocity corresponding to the minimum velocity will also be minimum. I mean to say that suppose v is the minimum velocity, and after reaching at this point, the velocity is v dash. Now I again give it a velocity v2 which is greater than v. So after reaching at this point, the velocity will be v2 dash. But of course, v2 dash will be greater than v dash. Similarly, if I give a velocity v3 at this point, then the velocity at this point will be v3 dash, and again this v3 dash will be greater than v dash. So that's why I mean to say that if I give a velocity v at this point, which is the minimum velocity, then after reaching the topmost point also, it will have the minimum velocity only. I mean, the velocity will decrease, but of course it will be minimum. And note it that if I give a velocity less than v at this point, then it won't be able to complete a loop. So now let's consider that I have given it a velocity that is the minimum velocity for the bob to complete a loop, and it has reached its topmost point with a velocity v dash. Now as it is executing a circular motion, there should always exist a centripetal force. I mean to say that without any centripetal force or the force acting towards the center, circular motion is never possible. This concept is in accordance with the Newton's first law of motion. So what are the possible forces that can act towards the center at the topmost point? Now, if we look carefully at this point or at this position, then the forces or the possible forces that can act towards the center are the tension in the string and weight of the bob. So, T plus mg equals to mv squared by r. Here T is the tension in the string, mg is the weight of the bob, and mv squared by r is a formula of centripetal force. Here v is v dash, I mean v square is v dash actually, that is actually v dash square. M is the mass of the bob and r is the radius of the circular path. Now, for the velocity at the topmost point to be minimum, this value, which is t plus mg, should also be minimum. Now, one thing is very clear here, that mg can never be 0, right? Because if mg becomes 0, then there is no gravity acting. So, that's completely irrelevant. Mg can never be 0. But yes, t can be 0. So, for the minimum velocity at the topmost point, the equation is mv squared by r equals to mg. Now do the further calculations. Now, on doing the further calculations, we see that v is equal to root over g into r. Now, as the bob comes down, it loses some height. Now, as it loses height, it loses some of its gravitational potential energy. And this lost potential energy gets converted into kinetic energy. So, in addition to the velocity at the topmost point, there comes a new velocity, which is the total of the minimum velocity at the topmost point and the velocity gained due to the gained kinetic energy. So, the total kinetic energy at the bottom, which is equal to half m s square. Here s is the final velocity at the bottommost point. So, half m s square equals to half m v square. This v is the minimum velocity at the topmost point, and then half m small v square. Here, small v, I mean half m small v square, is the extra kinetic energy gained due to the lost height. Now, according to the law of conservation of energy, this half m small v square should be equal to mg 2r. Now, why is it 2r? The reason is that the lost height is actually the diameter of the circular path. So it's 2r. Now we can replace the value of this v with root over g into r, as per I have proved. Now after all those calculations, s comes out to be root over 5gr, and this is the minimum velocity required at this point to complete a loop. So, in the video, the diameter of the tunnel was given to be 7.5 meter. That means the radius of the tunnel is 3.75 meter. Now, putting this formula in the formula that we have found, that is root over 5gr, the minimum velocity comes out to be 13.55 meter per second. Now, this is the minimum velocity considering that there is no friction and all. So now if we consider the air resistance and all the friction and all, then the value will increase. So according to estimations, it would be maximum 16 to 17 meter per second. Thank you.